Welcome to Wednesday. It's Wednesday, can you believe it? And it's Redis Wednesday, so it's the best Wednesday in like the entire year. I hope you guys brought your cameras. Take a picture of everybody celebrating the whole entirety of Redis, 10 years old or 20 years old now. It's a very old platform. It's an awesome platform. I'm Mario Gray. I'm the principal technologist at Pivotal. I work with the Spring team. I work with many of the PAs in the area. You've probably seen me in Santa Monica. You've probably seen me in London or Paris or one of the Spring tours or even one of the conferences in the area at a Jug in LA or a meetup. You probably remember me from a small video game called Super Mario Brothers. That's not me, that's my doppelganger. People tend to say, hey, it's a Mario, but I'm Mario. I don't know who that other guy is. So the actual thing about the demonstration will be about Spring Boot and Redis. So what we're going to do is we're going to talk about some reactive technologies, the new features that you're going to start seeing with asynchronous callbacks and scheduled tasks with the reactive reactor loop. And then we're going to merge that with our Spring Boot configuration and show how to do Redis operations in that. So what I wanted to do is point you over to the GitHub. If you have any questions about the sample that I'm going to show you today, go ahead and hit that GitHub right there and you'll find all the code necessary. Browse the repository and find other Redis-related code. You should find, it should edify your curiosity. If you have any questions about Redis, you can find me later on, and I will happy talk to you for 20 to 30 minutes. We can espouse why Redis is the best database for real-time operations or any sort of low latency operations or any operation for that matter, at any point in time today. Now, I have a history of programming. You probably see that. 2006, I probably started doing something like developer analyst for a big mainframe shop. I brought Redis into that to make stock quotes faster. We have, a gigabyte of incoming stock quotes from something like Reuters, and we need to be able to process it. So Redis was one of those things that I brought up and, championed for the company. I don't like to say champion because it means like you're doing really a lot of things. But I did. I pretty much championed for it. And every other place I've been to, it's been about, hey, let's bring Redis in because it's a really cool caching system, or it's got lists that are sorted, and you can do some really cool, tricks with it, like pub sub, or you can even do a fake pub sub where you're BL pushing or BL popping, blocking long pop, blocking left pop. So some really cool stuff that I've done with Redis, and I'm really glad to be here to speak to you about Redis. Come see me later on. Well, let's move on. Let's talk about what this demo is going to be about. Is anybody here familiar with the reactive methodology, the reactive programming methodology? Hands? A few hands, good. So you're probably familiar with concurrent futures, concurrency loops, event-driven engines, things that like Node.js would use or even Redis uses. It uses a like libuv, where you're dealing with a single event loop on a single thread. However, they're scheduled, so you're always dealing with a linear amount of work to do. Which means that you always have a constant amount of time to get things done. And in this case, we're going to really dive into what that means for our application. So let's get reactive. So what is reactive? So for those that don't know, reactive is our fully non-blocking foundation with efficient demand management. This means that I can say, hey, I want to subscribe to your stream, but I don't want everything in the stream. I only want some items. So this means that it's demand management. It's pushback. So it directly interacts with functional APIs for completable futures. It also works with the Java streams, and the duration, the time limits that you would want to account for your streams to get emptied or for the next event to happen. The types. So reactive offers two high-level types, multiple lower-level types underneath it, but we'll talk about the two high-level types, the flux and then the mono. So what is the flux? What is the mono? The flux is a boundless, unbounded stream. It basically says I have zero or infinite amount of elements in this collection or stream. Think about it like a collection. How would you treat a collection that's unbounded? How do you begin to describe an unbounded collection? Normally you don't, but with the flux you can say, hey, I'm always going to receive something, so therefore every time something happens, execute an operator. We'll get into that next. The mono is like the flux, but it's just 0 or 1. You're only ever expecting one answer, like a Boolean or something, or an error, or a completion, then you want to use a mono. So for things that have to deal with lots of messages or lots of events, use a flux. And when you just have one answer to give out, use a mono. Communications. So the reactive streams allows us to implement communication transports. And in this case, we're looking at something along the lines of HTTP, TCP, UDP, WebSockets, so on and so forth. Implement your own if you have to. But what this means is that I have the ability to swap transports in and out. You also have the ability to encode and decode data in and out of JSON, in and out of standard Java binary, or in and out of XML. So this is really good for decoupling how the stages of your application work. When you're talking to other microservices, for instance, you don't always talk the same language. You might need to use TCP one place, you might need to use Redis in another place, or use HTTP in another place. So Reactive Streams allows us to take that and take our transport with us. But we still talk to our core and our types the same way. So this is very important. So these are the 4 interfaces I spoke about. The Flux and Mono, they basically implement these 4 interfaces. You have a publisher of T, which is the type of element that you're going to get out of this stream. There is a method called subscribe, which says, hey, publisher, subscribe, and you give it a subscription. And that subscription tells us, here's the handle of the thing that I'm going to receive data from. The subscriber of T is the same thing, only it pulls instead of pushing, it pulls. It says, hey, I'm going to receive data, so every time I do unsubscribe, I will receive the handle of the subscription, and it'll tell me when the next data element is available. Then there's the subscription itself. I probably already talked about the subscription twice. Now you know what the subscription does. It lets us handle our data streams. And then there's a processor of T and R. Processor basically says, hey, I'm going to have an element coming in, and then I want to emit another type of R. So it's an amalgamation of both the publisher and subscriber. It's for doing things like transformation or fan-outs, or any sort of complex bidirectional, non-unidirectional communication. So these are very good to compose consistent, concurrent streams of data and have operators basically execute against your events. So let's talk about that. What are these operators? These operators are things that we use to go from a state in your stream from element 1 to element 1 prime, and element 2 to element 2 prime, and so on and so forth. If you look at a mathematical transformation, it's f of x equals y. That's what the operator does for us. So when you have filter, you're saying filter of x, and then everything that comes out of the filter is either true or false, which means we're going to drop elements, right? Same thing with map. However, map literally transformed. It goes from f of g to x. It changes the element. So I can go from a user object. I can say map that user into a chat user or some sort of a reified higher level object that I know that I'm going to need later on down the stream. Flat map allows us to take multiple dimensions of a synchronous computation. For instance, if I had a stream publish a bunch of fluxes, or if I had returned a flux within a map, I want to use flat map because that's going to turn that flux back into its original type. So it'll flatten it for us. So I don't have to dive too deeply into what a flux of a flux means. Just use a flat map, and you just get the flux itself. Zip, width, reduce, and repeat are all things that you'll probably see in collections, your collections library, where you're able to basically zip, literally interleave 2 collections together. In this case, you're just interleaving 2 streams. So these are very, collection-friendly. If you've used Guava or if you've used any of the Scala future libraries, you'll probably be very familiar with the Reactive library. In fact, I like to consider it closer to what when I started doing the Reactive, I said, hey, this is a lot more like the standard Java streams. But when you think about the asynchronicity, then it becomes more like a promise. You think about promises in JavaScript, you're pretty close to what Reactive does. What Reactive does in the background is a little more technical because you have back pressure and you have a re-implementable communication and serialization features. But behind the scenes, they act pretty much the same. So I like to talk about what we do next is we look at these marble diagrams. I spent a little bit of time just putting together a couple of marble diagrams that will allow you to understand what you're going to see in the reactive, the project reactor documents. This particular diagram, it's describing what happens in a stream when an operator is executed and then an error condition happens. So in this case, you have some state, right? In your stream, you have a mono here that has exactly one element. It's the state, it's 1. And what happens is your operator, for instance, your map may have said, hey, I'm going to take this 1 and do something to that 1. Maybe I'll multiply it by 2. However, you can also throw an error. And when that error happens, your stream has to be able to say, hey, I know what to do with this error. So you are given the chance to recover from that error, much like a try and catch. But in this case, you can do an error and say, or repeat. I can say, if this error is out, then I want to repeat this again. Or if it error is out, I want a default value, things like that. In this case, what you're looking at is the timeline of, this is time, and it flows from left to right. And as time equals 0, you have nothing. When time equals 1, you have your first element, which is 1. And then as time equals 2, something happened when it hit that operator, because it went down to the operator, and it shifted, and it said, hey, I have an error. And you got this X. For some reason, it terminated abnormally. This means that we have to, like I said before, you have to do some extra processing, catch your error using the on error or the repeat, and that allows us to essentially compose error handling and our application functionality with a very elegant API. So let's look at that for a second and then go on to what would you do if you had the following, a flux. It's the same thing. It's you have time going from left to right, you have your elements, 1, 2, your operator is actually executing against each one of these elements, and then somewhere along the way it hits an error, and you get this termination signal. Now, a termination signal doesn't have to be an error. Your stream can expire, or your stream can just stop. You can say, hey, I don't have any more elements, and instead of an X, you would get another completion signal. It would say, this stream is done, right? So you would say, instead of this stream is done, there's an error, you would have a positive one and say, this stream is just complete, and therefore stop subscribing to it. You can hang up. In this way, error handling is fundamental, as I said, but so is the completion as well. So you can also have uncomplete, and uncomplete lets us know when, it lets us compute something when we're done with the stream, when the stream is complete. In this case, you're seeing an error. So usually you'll just have an on error, do something, return a default value or whatever. All right, so how would I go along with this? If I was a person and I said, hey, I just saw like 4 slides on Reactive, now you expect me to code? Okay, good one. But you know what the best way that I've learned is to code and just to start coding and never stop, never look back. You're gonna remember half the stuff that you see. That's why there's GitHub, you're gonna love it. GitHub is a great tool. If anybody's not using GitHub, I suggest you use it now or start using it soon. Okay, if you're using GitHub but not Redis, that's okay. If you're using Redis but not GitHub, that's even better. But if you're using both, you're golden. So let's look at this demo application I wrote. I put this demo application together in the last several hours. Actually, I put this together for another sample that was part of Redis Day. And Redis Day was the seminal event in Israel, Tel Aviv, where we talked everything all about Redis, just like here, with a smaller audience. And I had a chance to really understand what people are looking at in Redis. And I've learned that people do a lot of really cool things in Redis. So I just wanted to show some things in Spring Boot. That's all. Like, I have a Spring Boot application, I'm going to test it, I'm going to demonstrate some operations, and that's it. So let's start this. Where do you normally go when you want an application? What is your favorite place in the entire world? There is only one place in this entire place that you guys, there is no start.redis.io that brings out a Spring Boot application complete with reactive Redis, but there is start.spring.io that allows you to create a Spring application with reactive Redis. I should talk to the guys over there about having a start.redis.io because that would be pretty cool. So with this application, I'm going to use start.spring.io. I'm going to select Kotlin. Does anybody have a problem with Kotlin? Is Kotlin Are we good with Kotlin these days? I like Kotlin. Kotlin's a great language. It allows me to think and then write faster than Java. I don't have to think about my keyboard so much. So this is for me. This is a gimme. Okay, so we're going to use Kotlin. We're going to use Maven. We're going to stick with 2.1.3. We're going to create a group called com Redis demo. We're going to make the artifact demo. We're going to say this is a Redis Reactive Spring Boot demo. And that's good enough. Package name will be com Redis demo. We'll make it a jar. We'll use Java 8. Oh, look, dependencies. Okay, so the first dependency I'm going to want here is Redis. So as you know, there are two choices. There's the imperative Redis, the blocking version, and then there is the reactive version. So I'm going to select the reactive version of Redis. That's because I want to be able to use reactive streams. And I'll show you how to compose and essentially create the Redis application from now. Now, I don't need anything else because I'm only starting with Redis here. So I'm going to go ahead and generate this project. Now, I'm going to slide over. You're not going to see that. Nobody saw that, right? Good. Because I have an application open right now that contains a lot of code. It contains about an hour's worth of code, literally 1 hour's worth of code. But I'm going to start with test. If you've seen me before, I've done Bootiful testing with Spring Framework. And this particular demo is almost no different. I'm going to test my application first. I'm going to show you how to test an application that's reactive using Redis and Spring Boot because it makes it simple and it's painless. If you've done this in the past with, say, Node.js, you probably have to have a container, launch a container, test your application with, the container, shut down the container, and that takes forever. In this case, let's begin. So what do I have here? Can you guys read that code? Let's make that a little bigger so the guys in the back can see what's going on there. 26. That's good enough. OK, so what do I have here? I have a test case. I have a bunch of test cases, but in this case, I have something called Redis demo tests. So I start with this here annotation, data Redis test. What do you mean data Redis test? We already know this is a data Redis test. Yeah, but this is a special test. So what Spring Framework has is the ability to exclude types. If you've used Spring Boot before or any Spring Framework, you know that when you start the Spring application, it auto-scans your complete class path, and it goes, OK, which one of these components am I going to wire up, turn into resources, and allow you to use? Now, in this case, I don't want that to happen because I want my tests to execute fast. So what do? I use a slice. I only want Redis stuff. This is what data Redis test allows us to do. So this annotation can be used in combination with the Spring Runner for a typical data Redis test when you focus specifically on Redis. And that's what we're doing here. We're focusing specifically on Redis components. So it's going to disable full auto configuration, and it's only going to apply configuration relevant to Redis. OK, so that was a little bit of an intro for Spring test slices, and understand that there are multiple test slices. There is a web test slice. There is a data JPA test slice. There's like Cassandra test slices. There are all sorts of test slices that allow your tests to run fast and for you to isolate your test coverage and to make sure that you're not testing things that you probably don't want to test while you're testing it because it can introduce error, and you don't want that variability. The next thing is I'm using JUnit 5, so I'm going to use the Jupyter API, which means I'll use the extend with annotation. So extend with is for Jupyter. Use it with the Spring extension class, so it'll bring in my application context. Next is this test instance. So this thing here, the lifecycle is per class. What this means is I have a before all, and in JUnit 6, these have to be static. And I don't want this to be static. I want this to be something that I can call over and over and over, and something that is on the class, that is a instant. So what I'm going to do is use before all. Now, if I got rid of test instance, it would complain and say, hey, no, you gotta, to use before all, you have to have it as a static method. But using test instance, I don't have to do that. Now, what do I do here? So the first thing I want to do is I want a logger. I want to port. This is my test Redis. Here is my Redis server. This is a variable. These are the variables that I'm going to use to wire in a Redis server. A configuration factory to actually connect to my Redis server, which uses Lettuce. So this is the Lettuce configuration factory using the Lettuce driver. And then the template. So this template allows me to talk a specific flavor of objects for key and value. OK, so why all of this setup, Mario? Like, what's the deal here? Well, this is what I did. I did something a little different, And I like this because it works really well. I am using this guy. His repository is it.ozimov, and he has something called embedded Redis. And what is embedded Redis? It's probably better than sliced cheese, but who knows? What it allows us to do is download Redis, launch it in a thread just for that one test scenario, and then tear it down when that test scenario is over. In this case, I allowed it to do that by setting up a Redis server. So once I set up my Redis server, I say, hey, go ahead and assign it, start up Redis on port 6777, start the server, and let's get a driver and connect that to our newly created and started Redis server. So when I have Redis configuration connection factory, I'm telling it, hey, connect to 6777. That's my test Redis. Call after property set, let us know that, hey, you need to configure, you need to become an instance. And then finally, wire together a template. A template is something like this. So this is a configuration for a template, for a Redis template. This is a reactive Redis template. Basically, anything I put in here will have to talk how to get the key out and how to get the value out of that key. So essentially, I'm saying everything here is a string. I'm getting strings for keys, and I'm getting strings for values back. What I did is I configured it using the Redis serialization context builder, and I said here, create a serialization context for transforming strings in and out of Redis, okay? And then I told the builder, for every key, you're going to use a string serializer. For every value, you're going to use, of course, a string serializer. This is a string Redis template, so everything here is strings. Same thing with hash keys and hash values. You basically decide, how does Redis see your keys? How does Redis see your values? And you give it a serializer, deserializer for that. So in this way, you're able to talk to your cache or to your database, to your Redis database, in a manner that's really applicable to your application. So we'll move on from the string one, and I also configured another template that's just a little bit more of a variance from the string one. In this case, I have keys that are strings, and then I have actual values that are messages. And I have this high-level object called a message. Data class and Kotlin are beautiful. All I have to do is say data class, and I'm done. This contains 3 pieces of state, an ID, a name, and a message. Simple as that, right? Yeah, Mario, but how do you actually make that work? Well, same thing I did before, create the template using the context serializer, create a new context, tell it you have keys that are strings, and you have values that are, well, they're going to be JSONified messages. So I'm going to expect JSON to go into my Redis cache. So instead of a string for the value, I'm going to expect JSON as the value. So we'll show that a little bit later. But the template has to know how to get that particular encoded information back into a POJO. So this is why I'm using the object mapper. The object mapper lets it go from value, which is a string of JSON, to a reified object type of message. So now, let's move on. What happens after this whole test is done? The server stops. Shut the server down, because if you don't do that, and if you were me about a week ago and you were testing going, hey, why are there like 20 different Redises working right now? Well, that's because I didn't stop the server. So always stop your Redis servers and test. All right, so my first test is going to be this guy here. So the first thing I wanted to do is see well, how can I test if this connection factory even works? How do I know if I'm actually connected to Redis? Well, that's easy. You can ping it. There's actually a command called ping. And so what I did was I told the template, give me your connection factory, and then give me the reactive connection, so that way I can talk flux and mono, and then ping it. Now, because it's ping is going to return a string. Remember, if you do Redis ping, it returns in pong, right? So all it does is say, hey, ping, pong. So I say, give me the ping and test it within a stream. So now I have a stream. This will emit a single stream containing one element, pong, right? So look at this. There's a mono. It's going to have one value in it, and it's going to be a string. And because it's Redis, it's going to have the word pong in it. Now, how do I test that? This is I guess, one of the bigger components that I want to get through here. This is the step verifier. Now, when you're testing concurrent code, when you're testing code in a reactive loop, in a reactive event loop, you have to be able to control which events are happening when, right? You have to be able to say, I'm going to expect one event, and then I'm going to have to wait, and then I'm going to expect another event. Well, how do you model that? The step verifier allows us to model that and actually ensure that we were getting the responses that we're looking for. So if I read the documentation, it says, step verifier provides a declarative way of creating a verifiable script. So this is important. It creates a script, basically, for an asynchronous sequence by expressing the expectations about the events that will happen upon subscription. So once I subscribe to my mono, to that ping, it's going to expect something else to come out of it. I'm going to write an assertion for that. So the verification must be triggered after the terminal expectation. Like we saw before, the terminal expectation could be an error, it could be completion, or it could be a cancellation. In this case, I'm not expecting anything else but a completion. So once those are declared, I can call the verify method. Verify is saying, hey, pull the data down and ensure that there's stuff in there. I also call on a verify complete as well. You probably see that down here. So anyway, let's go into the step verifier. So I created an instance of the step verifier. In order to create an instance of the step verifier, I give it something called, I give it my publisher. That ping right there, that variable, is actually one of these. So this is a reactive publisher now. That basically is a mono. Of course, mono implements publisher, but basically tells me that I've got a publisher that's going to contain an element or many elements. I don't know. It's a publisher. It could be either flex or mono. In this case, we know it's a mono. So I create the instance of step verifier with my publisher, and then I said, okay, well, expect there is a subscription that happens. You have to always subscribe to your streams. If you don't subscribe, then nobody's going to know what's happening in there. In this case, it's actually not even useful to have an expect subscription because it's implicit. So I just like to put that there because there might be another intermediary step that you don't know about. If you're programming on a contract where you have multiple people or multiple consumers, you're not going to expect a subscription all the time. You might have to wait for a subscription or maybe for 5 subscriptions to happen first. In this case, I just want one subscription. The next thing I do is I have my assertion. I have an expectation. So all it does is it peeks inside of the stream and says, hey, what's there? And then it expects it to be next. It expects it to be Pong. I have that one element. It says, hey, what's in there? Expect it to be Pong. If it's not, then error out. So let's actually make it error out and see what happens. What does it actually look like to error out within a reactive test? Okay, so should ping error it out because my template hasn't been initialized. But of course. Let's use that guy there. There we go. So Redis, the reactive Redis for Spring Boot also comes with a directive, with it supplies a template, a built-in template that does strings already. I just did this string as an exercise. I want to make sure that I can talk to the string, to the template, and I want to make sure that I can get strings in and out of it. Oh, reactive. There you are. It's going to be reactive. So remember to use the reactive types because otherwise you will get the blocking types. And give me the reactive connection and then give me a ping. There we are. Now execute. Okay, so what we want to do is we want to make sure that we are only lining up with, there we go. So that failed because, well, obviously it's going to do that to me now. No problem. Don't you hate it when that happens? Loading. I think it's loading. It should be loading. There you are. Okay, same test. So my to ping here, this test should ping, run me, you naughty test, you. When your tests are naughty, who do you blame? The tester. Always blame the tester. Remember to PR everything until people are very aware what you've just PR'd might not work. Parameter 0, required a bean type of reactive Redis template could not be found. Of course, you're going to do that now. Right. Import. There we are. I want to import my config. You can import specific pieces of config, because if you have an auto excluder, then you're probably going to exclude more things than you want. In this case, I'm going to import a particular configuration, which is my Redis config that you saw earlier. I bound both templates together. Okay, so now I'm dealing with a stack trace, test ignored. Failed to load application context because, righty. Wow. Okay, well, I'm not going to worry about that. I'm going to move on. If it wants to give me that now, that's fine. I'm cool with that. So my ping will emit a pong. That pong will go, okay, well, if it's not there, I'm going to throw an error. If it's there, good. And the other, moving on, back to my regular test. Let's go into another one. Let's do P2. Let's add another test to this. Whoa. Okay. Well, my stuff just blew up, but that's fine. I'll just defer here. All right. So the main test. How do you talk to Redis? How do you actually get data in and out of Redis? What I want to do here is show you what it looks like to create a Redis operation that will get data and set data. So in this case, I have a put. And what I want is a publisher that at the end of the stream will say, yes, I put data, or no, I didn't put data. So what we're going to get is, we'll have a Boolean. That Boolean will tell us whether the operation succeeded or whether the operation failed. So for get Redis operations, you want to do this. So I have the template. Remember this guy here. I have the reactive Redis template. I want to grab its operations for value. And what does this allow me to do? So in the template, you have multiple ways of talking. You can say, hey, I have a key value set that I want to get, or I want to talk to a hash, or I want to talk to a hyperlog log, or I want to talk to a list. You can do all of these by using the ops for, and then the type of thing that you want to talk to. So in this case, it's a value. It's just a key value store. So I'm going to say set a key called test to the value of 1, 2, 3, 4. And then to get it, I'm going to say get operations for value again. However, retrieve the value out of test. From that, I have two publishers. One publisher is going to, at the end of the day, push data in, and the other publisher is at the end of the day going to receive data and return a string. So the first one's a Boolean, the next one's a string. So how do I compose that? How do I make sure that one thing happens and then the next thing happens, right? So I want the set to happen first, and then I want the get to happen after that. With reactive, you would use this. Operator is called flux.from. So what this is telling me is execute this particular publisher until it's completed, and then either return the value or do something else. In this case, I'm saying drop the value as long as it completed successfully, and then execute the next publisher that will return a flux. So then many. If I said then, there is a then, but that requires a mono, right? So I want to say then many because I have many things coming out of here. Maybe I have one thing, or maybe I have an infinite amount of things. So what I did was I composed it and said, okay, well, do A, do B, and then we'll see what's coming out of the stream after that. So in this case, I did create the step verifier. I said, here is my composed flux that does both the set and the get. Expect my subscription, and then assert that the value that I got out of there was the thing that I put in there in the first place. In this case, I have a matcher, which I use Hamcrest. If you're familiar with unit testing, you use something like Hamcrest to essentially lock up portions of your test logic into things like a particular matcher. And this matcher here will ensure that it's not null, and it'll ensure that it has a specific state. And that's what's important. That's what I want to do is I want to know that the state's the same. So I use my assert next. In assert next on the step verifier, unlike expect next, which was an equality, assert next is saying, hey, you're going to execute some executable. You're going to make sure that that thing doesn't accept. So I'm going to run like maybe an assert J assertion, or I'm going to execute a JUnit assertion. In this case, I'm going to use a Hamcrest assertion and ensure that the state's correct with what the ID matcher expects. So I have a match assert that receives value for key is my heading. This is the actual value, so it can be it. You can actually, in Kotlin, you can just use the it, and that becomes the thing that you're talking to. And then to match it against my ID matcher, and then verify that it's complete. So once again, let's see if we could run that again. What did happen earlier was I had tests, and then I didn't have tests. Suddenly I don't have tests, which is fine, but like most of the time you want tests, you want to show people your tests. So that was the easy one, right? That was like get set. We've done lots of getting and setting. There's an even more important one that I want to show. I feel like it might be a little complicated, but it does deal with pub sub. So because you can pub sub with Redis, and it's one of the fancier features, it allows you to do fan outs if you're reading from a queue like Kafka, or if you're reading from something like RabbitMQ. You can have many Redis readers on a topic receiving information and sending it out back to maybe WebSockets, things like that. It's extremely fast, very lightweight and resilient. Use it all the time at everywhere I've worked. Now, this particular test here, I would go over it later on with you guys if you want to, but it just makes sure that what was published was received. In order to do that, you have to set up a flux that receives the messages that were emitted from the publisher. We're not going to go into that now because that's a lot of code, right? And we only have like maybe 10 minutes left. Let's go into something more important. Let's actually do the demo. Let's do the real demo. Now that you know how to test Redis with data Redis test, you know how to use the, you know that if you have the embedded Redis in your dependency tree, that will give you the Redis server that you can start up in our before. So I can say, hey, start up a whole new Redis server. So this is good stuff to test with to make it much more agile within your testing regimen. But let's talk about the demo. Let's see what we're doing in our demo case. So what we're doing here is I'm using both the geo and the standard get set and maybe some lhop and lpush. I'm doing all the operations, and I'm going to go one after the next. I call this a smoke demo. This is basically a smoke test. First of all, let me ensure that this guy here will execute, unlike that test, that naughty test. Those tests can be naughty. If you've dealt with tests inside of your CI loop, you're going to want like really good stack traces, right? You're going to want to know how to get to the bottom of that test that failed so that you can, make that thing work again. Okay, so this guy here has a particular output. I will copy and paste it into a buffer so that we can look at the output later on. But first of all, I have keys. I have a geo key. So this is the thing I'm going to use to store my latitude, longitudes, and hash keys, right? Or keys. The topic key. It's the thing that it's the topic that I'm going to listen to. It's called ring topic. I have a list. The list is a thing that I'm going to store a bunch of IDs in so that I can pop them later on. And then I have 3 instance variables. I have something called a ring, and they just have 3 pieces of state, an ID, an alloy, and a size. So if you've ever worn a ring, you probably have like size 9 or 3 plus or 2 plus. It's the same thing. It's just, imagine if I had 3 rings, gold, silver, and bronze, and I gave them coordinates. I put one ring in Spain, I put another ring in Europe somewhere, London, and then that third lat long is, I think, in the same vicinity. Maybe Turkey. I can't tell because I don't know how to read Latlan very well, but I'm pretty sure you understand. I'm distributing things in space. So let's go on with our application. I have a title. I have this thing here. It's actually an application runner. This is going to allow me to execute my Spring Boot application using this guy here. So I call it Reading Cache Demo. I give it 2 properties for assignment. I have a template for getting strings, putting strings into a key, and getting rings out of Redis. Remember, they're JSON encoded. Then I have another one just for string because I only want to talk strings at this point. So whenever I want to talk about strings, I use ID cache. Whenever I want to talk about rings, I use the ring cache. That allows me to talk specifically to my application. So I set up my operations. I have a geo operation, I have a value operation, and I have a list operation. So I have 3 different operations I'm going to compute here. I created a fan-out processor. You can ignore that. That fan-out, that little guy right there, he's the naughty boy from last time. However, this guy here, what he's going to do is our pub sub. He's going to allow us to put data into Redis. So first of all, I create a processor. Remember, the processor is both in and out. So what I want to do is, I want to say, okay, well, give me a string, let me talk strings, give me the reactive connection to those strings, give me the server commands, and flush everything. So the first thing that my application does is it flushes Redis. So that's why I called it flush flux, because it's a flux that will just eventually flush everything out of Redis. So that's the first thing that happens. The second thing that happens is I subscribe. I create this fan-out processor. This is a particular flux. This is a particular reactive component called the processor again. This is going to allow me to send elements into a flux and then receive elements out as well. So what I did here was I said, okay, well, handle, whenever you get a data, put it into your stream and then map it. So you're going to get a string, and that string is going to be representative of an ID. And whenever you see those strings, go ahead and convert and send, put it into the topic. Remember, we're going to push it into a Redis topic. We're going to put that ID into a topic so somebody listening will see an ID. And then for lists, because I want to do the same thing, but for lists, I want to also talk to a list as if it were a pub subtopic. So I'm going to go ahead and left push it into a list. The next thing I'm going to do is I have this flux that happens to read both things. It reads the topic and it reads the list. So what does this mean? So I have listen to. This is my pub sub listener. I'm saying channel topic, topic key. So now we're listening to our topic. And then I'm saying every time you get something, you're going to do the following. So you're going to do flat map. And flat map is going to say, hey, this guy's got like a synchronous I/O happening in the background of this operator. So we want to map it down and reduce it to its original flux. What I'm going to do is say ring ops, get a message. So it's going to do asynchronous call to Redis saying, hey, get whatever was in this message from this topic, and then get its geo position for that key. So that key has a geo position, and I want to get that geo position out of there. And that's why you see the following. So when you see the word topic here in this buffer, you see topic, ring topic is the name of the topic that I gave it, and then the data that was consumed, which was an ID, I was able to get out of the cache using the key and value. And I said, okay, well, what was it? It was a ring, ID 3, it was bronze, it was size 3, and the actual geo data that came out of it as well. Here's a latitude and longitude. How did I get the geo data out of there? Very simple. Once I got the subscriber.message, which was an ID, I was then able to say, hey, give me the position for this ID. So I talked to the string cache or the geoops and said, give me the position for this ID. It returned a point, and that type of this type of data is a point that returns a latitude and longitude. And I was able to create another bean called the ring geo that contains a ring and its latitude and longitude. And then do on next, I just printed it out. So same thing with the list. I read out of a list, I do, hey, left pop out of that list that I pushed into, right? And remember, if we do blocking pop, if I do a blocking pop, it'll just sit there asynchronously and wait forever. So that's what I wanted to do. I said list ops, left pop, list key, and here's a duration that you should wait for. So that BL pop will take 2 seconds or it'll time out. So this is important because you don't want them listening forever, and you want to be able to tell your subscribers downstream, hey, we timed out. So in this case, I have a 2-second timeout, and then I'm able to take that same data, which is an ID, grab its key, grab its location, merge them together, and say, here's what I got out of that list. So it's the same thing, ring inbox.pop is what I called it if you look at the code here, and I have my data. Now, the storage part is another side of the story. It basically says, hey, I'm going to push data in there, but remember, this all happens behind the scenes. And then composition. So I have composition. I'm able to merge my fluxes. I'm able to say, hey, put all your data in, and then subscribe to that. Now, the next thing is, once you're done, once that subscription is done, because it blocked, I blocked here when I did subscribe, okay? So you normally don't want to do that. Right? You want them to happen asynchronously on another thread, but in this case, for this demo, it works. I can just say subscribe. I can expect it to be done by the time I get to the next line of code. So then I said flush it. Well, then I said, oh, well, the first thing I did was I processed it, didn't I? So process, read, and read. So I said here, 3 things that are just going to sit there and read, and then the next 3 things are going to write. So I have my readers and my writers. Once I subscribe to them, then they drain. And once they're drained, I'm able to print out, I'm able to see the results of this application, which is just, hey, this is the data that came out of that topic, and this is the data that came out of that particular list. So I think that works as a demonstration. However, if you have any questions, do see me, do look at the GitHub, and do understand that this reactive thing is really cool. It allows us to talk to Redis in a very fluid manner because it's asynchronous. It allows us to say, hey, I have a compositional application. I have application logic that I can compose asynchronously with a very high-level API. And Spring Boot allows us to basically glue it all together in a really easy way. The fabric of the applications become very much simpler once you reduce the amount of strain used for blocking code. And that's it. Thank you very much. Let's look at one more slide, actually. That's it. Now that's it. Now we're done. Thank you very much.